Waves are an oscillation that travel through a mediation and transfer energy. There are multiple kinds of waves, but as you can see, I've written down two different waves. One of them is a longitudinal wave, which are oscillations that travel parallel to waves' motion. As you can see from the picture, it almost looks like a barcode. And then there's transverse waves, which are oscillations that travel perpendicular to waves' motions, which looks more like a stereotypical wave. The wavelength is the distance an oscillation travels during one cycle. The wave motion is a movement of a wave-like pattern from one location on the medium to another. And particle motion, which we aren't going to talk too much about this time, but you will see later in a video, is the motion of particles in a wave. As you can see, there are different parts of the wave. So, a crest is what looks like the top of a transverse wave, while the trough is the bottom of the wave, or the lowest point of the wave. Then the A with the arrows that you can see on the diagram, that's the amplitude. The amplitude is basically just how long the distance is from the crest or the trough to the center line of the wave. And then once again we can see the wavelength, which is from crest to crest or trough to trough, or any point really on the wave from one point to the other exact point. Alright, so as we can see here, we have a basic wave going on. When you raise the frequency of the wave, you can see that the wavelength becomes shorter than it would have been before. But when you raise the wave speed, the wavelength becomes longer than it would have been. Amplitude also has no effect on wavelengths. But as you can see, when you raise the frequency, wavelength is lower or shorter. When you lower it, wavelength is higher or longer. Wave speed, when you lower it, wavelength is lower. When you raise it, wavelength is higher or longer.